So this question says a person has 100 feet of fencing and she wants to enclose a rectangle. And then it says, let X represent the width and Y represent the length. Construct the appropriate equation that uses the fact that there is 100 feet of fencing. X is the width, Y is the length. So let's draw a rectangle. X is the width, Y is the length. So if this is a rectangle, this would be X and this would be Y, width and length. Well, if it's a rectangle, this is also X and this is also Y. And we know that she has 100 feet of fencing. So we put all these things together, right? All the way around has to equal 100 feet. So X plus Y plus X plus Y has to be 100, or 2X plus 2Y has to be 100. So that's the equation that uses the 100 feet of fencing together with the length and the width to determine that relationship. Okay, what's the next thing it asks us to do? Solve for Y in that previous equation. Well, that's easy enough to do. So I have 2X plus 2Y is 100. To solve for Y, we'll subtract 2X from both sides. And we get 2Y is 100 minus 2X. So then divide both sides by 2. So I get Y is 100 over 2 minus 2X over 2. So then Y is 50. 100 over 2 is 50. Minus 2X over 2 is X. So we've solved for Y. We have our relationship with the perimeter of the rectangle with width and length, and we solve for length Y in terms of the width. So we have Y is 50 minus X. What's the next thing that it asks us to do? Use the fact that the area of the rectangle is length times the width to find the formula of the area using only the variable X, okay? So area here, right, area is width times length. Area is X times Y, we see that. But we also see here that Y is 50 minus X. So if that's the case, we can construct an equation for the area, right? Area equals X times Y, so area equals X times 50 minus X. And let's distribute that X just to make it easier to work with. X times 50 is 50X minus X squared. So now area as a function of X, I'm going to write the X squared first. We usually prefer it in decreasing powers of X. Area as a function of X is negative X squared plus 50X. And this is a quadratic function. Area is a function of X, which was the width. What's next? It says find the vertex of the parabola described in the previous formula. Okay, so this is a parabola. We have a of X is negative X squared plus 50X. And that is a parabola. A of X is negative X squared plus 50X. For emphasis, we could say A of X is negative 1X squared plus 50X plus 0, right? And in general, if we have a quadratic function, f of X is ax squared plus bx plus c. So if that's the case, a here is negative 1, and b is 50. C, if you're interested, is 0, but it's not terribly relevant. We want to find the vertex of this, and we know that the vertex will occur at x equals negative b over 2a. So in our example here, negative b, negative 50 over 2 times negative 1, negative 50 over negative 2, which is 25. So the vertex occurs at x equals 25. Now, let's remember what our situation was, right? We had drawn a rectangle like this, right? We said this was x and this was y, and area was x times y. So fine, x is 25 here, and x is also 25 on that side. But you'll also remember, what did we say on the previous page? We said y was 50 minus x. Again, because 2x plus 2y was 100, 2y was 100 minus 2x. Y, the length, was 50 minus x. So using that fact, what could I say? Fine, y is 50 minus x. So y is 50 minus 25. So y is 25. Also 25. So notice, what kind of a rectangle is this? This is a rectangle that happens to be a square. So what were we supposed to answer next? Find the value of x that yields the maximum area. Well, our vertex of our parabola, we really haven't answered that question yet, have we? Because our parabola was negative x squared plus 50x. So let's go back and answer that first. So a of x is negative x squared plus 50x. I need to see, what is a of 25? If x is 25, what is the area? What is a of 25? That's negative 25 squared plus 50 times 25, which is, and let's take a look. Remember that negative is not in parentheses. Negative 25 squared plus 50 times 25 gives me 625. So a of 25 is 625. So the vertex of that parabola, right? The vertex, which is the form x comma a of x, right? X is the width, a of x is the area. A was 25, and area is 625. It's easy to confuse y and a, right? Because normally we think of y as a function of x. Here, a is a function of x. Y is also a different function of x. Y was 50 minus x. So the width is 25, the length is 25, the area is 625. Now let's try to answer the question as it's stated. What value of x yields the maximum area? Well, 25 feet, right? So we'll say that when x is 25, or when the width is 25, the area is maximized. When x equals 25 feet, or the width, remember x was the width is 25 feet. The area is maximized. And then finally, what does it ask me? What is the maximum area of the enclosed rectangle? Well, what did we say? On the previous page, we said the vertex was 25, 625. When x was 25, the area was 625. Or x times y, if you want, 25 times 25, also 625. So the maximum area is 625 square feet. Let's look at a picture of this as well with the graphing calculator. So we've got a of x is negative x squared plus 50x. We think the vertex, based on our analysis, we think the vertex is at 25, 625. And since this is opening downwards, that will be a maximum. The range, by the way, goes up to 625. Range doesn't really go to negative infinity here because it makes no sense to have negative area. Just something to think about. But I'm going to adjust my window accordingly so I can see 25, 625. So let's go to the graphing calculator and go to y equals, and that equation is negative x squared, negative button is here, negative x squared plus 50x. And I need to see x is 25, so my window's got to go beyond 25. So maybe negative 10 to 50 is a pretty good choice. I've got to go up to 625. So I don't know, maybe negative 100 on the Y min to maybe 1,000 on Y max. And we'll scale it at 100. And I can probably X scale it at 10. That would be better to scale it at 10. So this should give me a decent image. Let's look at it. And can I see what the maximum is? What is the maximum X? And what is the maximum value of the function of X, which is the area? So second calc maximum is number 4. A little bit to the left of the maximum point, hit enter. A little bit to the right of the maximum point, hit enter. The guess. And it's telling me a max occurs when X is about 24 and the maximum area is 625, and that's what we said.